Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 3, Projectivities of the Primitive Geometric Forms of 1, 2, and 3 Dimensions. Section 22, Perspectivity and Projectivity. In Chapter 2, Section 13, we gave a definition of perspectivity. This definition we will now apply to the case of two primitive forms and will complete it where needed. We note first that, according to the definition referred to, two pencil of points in the same plane are perspective, provided every two homologous points of the pencils are on a line of a flat pencil, for they then have the same projection from a point. Two planes of points are perspective if every two homologous elements are on a line of a bundle of lines. Two planes of lines are perspective if every two homologous elements are on a plane of a bundle of planes. Two pencils of lines in the same plane are perspective if every two homologous lines intersect in a point of the same pencil of points. Two pencils of planes are perspective if every two homologous planes are on a point of a pencil of points. They then have the same section by a line. Two bundles of lines are perspective if every two homologous lines are on a point of a plane of points. They then have the same section by a plane, etc. Two bundles of planes are perspective if every two homologous planes are on a line of a plane of lines. They then have the same section by a plane, etc. Our previous definition does not, however, cover all possible cases. In the first place, it does not allow for the possibility of two forms of different kinds being perspective, such as a pencil of points and a pencil of lines, a plane of points and a bundle of lines, etc. This lack of completeness is removed for the case of one-dimensional forms by the following definition. It should be noted that it is in complete agreement with the previous definition of perspectivity. As far as one-dimensional forms are concerned, it is wider in its application. Definition: two one-dimensional primitive forms of different kinds, not having a common axis, are perspective if and only if they correspond in such a one-to-one way that each element of one is on its homologous elements in the other. Two one-dimensional primitive forms of the same kind are perspective if and only if every two homologous elements are on an element of a third one-dimensional form not having an axis in common with one of the given forms. If the third form is a pencil of lines with vertex P, the perspectivity is said to be central with center P. If the third form is a pencil of points or a pencil of planes with axis L, the perspectivity is said to be axial with axis L. As examples of this definition, we mention the following. Two pencils of points on skew lines are perspective if every two homologous elements are on a plane of a pencil of planes. Two pencils of lines in different planes are perspective if every two homologous lines are on a point of a pencil of points or a plane of a pencil of planes. Either of the latter conditions is a consequence of the other. Two pencils of planes are perspective if every two homologous planes are on a point of a pencil of points or a line of a pencil of lines. In the latter case, the axes of pencils of planes are coplanar. A pencil of points and a pencil of lines are perspective if every point is on its homologous line, etc. It is of great importance to note that our definitions of perspective primitive forms are dual throughout, i.e. that if two forms are perspective, the dual figure will consist of perspective forms. Hence, any theorem proved concerning perspectivities can at once be dualized. In particular, any theorem concerning the perspectivity of two forms of the same kind is true of any two forms of the same kind. We use the notation P in square brackets to denote a class of elements of any kind, and denote individuals of the class by P alone, or with an index or subscript. Thus, two ranges of points may be denoted by P in square brackets and Q in square brackets. To indicate a perspective correspondence between them, we write the range P is perspective with the range Q. The same symbol is also used to indicate a perspectivity between any two one-dimensional forms. If the two forms are of the same kind, it implies that there exists a third form such that every pair of homologous elements of the first two forms is on an element of the third form. The third form may also be exhibited in the notation by placing a symbol representing the third form immediately over the sign of perspectivity. Thus, the symbols denote that the range P is perspective by means of the center A with the range Q, that each Q is on a line R of the flat pencil R, and that the pencil R is perspective by the axis A with the flat pencil S. A class of elements containing a finite number of elements can be indicated by the symbols for the several elements. When this notation is used, the symbol of perspectivity indicates that elements appearing in corresponding places in the two sequences of symbols are homologous. Thus, 1, 2, 3, 4 is perspective with A, B, C, D, implies that 1 and A, 2 and B, 3 and C, 4 and D are homologous. Definition: two one-dimensional primitive forms, sigma and sigma prime, of the same or different kinds, are said to be projective, provided there exists a sequence of forms, tau, tau prime, tau to the nth power, such that sigma is perspective with tau, is perspective with tau prime, is perspective with is perspective with tau n, is perspective with sigma prime. The correspondence thus established between sigma and sigma prime is called a projective correspondence, or projectivity, or also a projective transformation. Any element sigma is said to be projected into its homologous element, sigma prime, by the sequence of perspectivities. Thus, a projectivity is the resultant of a sequence of perspectivities. Footnote: this is Poncelet's definition of a projectivity. It is evident that sigma and sigma prime may be in the same form, in which case the projectivity affects a permutation of the elements of the form. For example, it is proved later in this chapter that any 4 points A, B, C, D of a line can be projected into B, A, D, C, respectively. A projectivity establishes a one-to-one correspondence between the elements of two one-dimensional forms, which correspondence we may consider abstractly without direct reference to the sequence of perspectivities by which it is defined. Such a correspondence we denote by sigma is in a projective correspondence with sigma prime. Projectivities we will, in general, denote by letters of the Greek alphabet, such as pi. If a projectivity pi makes an element sigma of a form homologous to an element sigma prime of another or the same form, we will sometimes denote this by the relation pi of sigma is equal to sigma prime. In this case, we may say that the projectivity transforms sigma into sigma prime. Here the symbol pi is used as a functional symbol acting on the variable sigma, which represents any one of the elements of a given form. Footnote: just like f of x, sine of x, log of x, etc., the definition of variable is a symbol x which represents any one of a class of elements of x. It is in this sense that we speak of a variable point.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.